Welcome back, everybody. So our next question is jump game 2. It's a very important question. Most of the company ask this question. It's a very popular question as well. So now let's read the statement. Given an array of non-negative integers, you are initially positioned at the first index of the array. Okay. Each element in the array represents the maximum jump time at that position. Your goal is to reach the last index in the minimum number of jumps. You can assume that you can always reach the last index. Okay. So input is nums 2, 3, 1, 1, 4. So according to this statement, I will tell you. So from 0th index, you will go to the first index, and first index directly you go to the last index, and that number of jump will be 2. Now, if you want to go like this way, like 0 to 1, 0 to 2, then you will go 2 to 3, then 3 to 4. Then the jump will be equal to 3. But I don't want that thing because I want the minimum number of jumps, so that will be equal to 2. So in this case as well, from 0 to 1, from last 1 to last index. Okay. Now let's understand the logic. Okay. Test cases 2, 3, 1, 1, 4. So today I'm going to tell you about two approaches. Okay, about two approaches. My first approach is like this. Let me do this thing. 1, 3. You are going to use a dynamic programming approach. In this approach, what we'll do, what we will just iterate over all the i's, and we'll just keep the minimum number of jumps for all i's. Okay, and with that help, with the help of that all minimum number of jumps, I'm going to get the final result here. So let's look at how I'm going to build this array. Okay. So now suppose if you are at the 0th position, that index first. 2, 3. Where the 0th position, tell me what is minimum number of jumps required. That is 0. Okay. Initially at the starting position, and your jumps will be equal to 0. So I will initialize my array as 0. That is jump of 0 is equal to 0. Now, if when I reach this position, then I will check my previous values. Okay. So suppose if I'm at the highest position, so what I will do, I will check from 0 to I minus 1 all the positions whether I can reach the particular I position, that is current position for which I am checking. I am able to reach. Then what is the minimum of all the position from 0 to I minus 1 from where I can reach to ith position. Okay, let's understand this one. So suppose I want to reach this position 1, I can go to this position. So can I go to this position? Yes, I can go from 0th position. I can go here. And the number of jumps will be equal to 1 because from if you are 0 position, then you will jump to this position. Okay. Now tell me what is minimum number required to go into 2. So how will I do? I will check. Can I reach from 0th position to this position? Yes, I can reach. The minimum number of jumps will be equal to this 0 plus 1 because if you are 0 position, you have to take jump, and minimum number of jump required for this position is equal itself 0. So minimum jump will be equal to 0. Not minimum number of jumps. Now can I go to this position from this position? Yes, I can go. How will I go? I will take a jump from this position to this position because maximum reach is 4th index. So minimum jump going to this position is 1 and maximum reach is 4th position. So when you are at this position, minimum jump is 1 and you have to jump to go to this position. So these are the values, and you have to you want minimum. Okay, minimum is 0 plus 1. That is directly from 0 to this position. For this position, what I will do, 0 to position, that will be equal to infinity. Why infinity? Because I can't reach to this position from 0th index directly. Okay, so from this position, yes, I can go 1. That is 1 index. A direct jump here from here as well. 1 plus 1. The minimum of all this. Now, if you want to reach at the last position, can I reach from this position last position? No, because 0 plus 2 is less than or equal to 4. Less than 4, sorry. So infinity, you can't reach this position. Can I reach from first position to last one? Yes, because minimum number of jumps required from going to from one position to this position, you go to 1 plus 3, that is equal to 4, and you can reach it. And minimum has to reach to this position, that is one position, 1, 1 plus 1. And from this, can you reach this position? No, I can't reach this position. Tell me why? Because maximum reaches this 3, like this thing. And when I reach the last position, that is third position, can I go to this position? Yes, I can go, because maximum reaches from this position. The minimum number of jumps equal to 2 plus 1. So minimum of all those will be equal to 2. This will be my answer. Okay. This is my answer. So time complexity of this approach is r square. Well, this was a little bit easier approach to understand, but I want the optimized one. Okay, so in the next approach I'm going to tell you the optimized one. Let's look at the optimized one. Okay. Now 2 3 1 1 4. Suppose in this method what we are going to do, I am going to make a statement. Let's just listen my statement. Suppose if I know for any particular ith position, if I know what is my at least jump, that is my minimum number of jumps. If I know for that particular I, that is what is the at least jump to reach at that index, then that is my answer. Okay. For example, like if you want to reach this position, then I know my at least jump. You have to jump at least one. That is this, because you can go like this as well and this as well. But I know at least I have to take this one jump to reach this position. Okay. Now suppose I have reached this position and I know that at least this one jump is required to reach this position. Then and I also know that after this position, I am going to take one more jump, because I know that but I don't know that I'm from which index I'm going to, from either I can jump from this 3 to next any index, from 1 to next any index, that I don't know. But I know that I'm going to jump after this index if I want to go the index which is greater than second index. This is because my maximum reachable index from my initial position is this. Either you go to this or either you go to 2 to 3, and you have to jump before or you can say that uh, or before 2, before 3 index, like for 2 and 1, 2 and 1, from 1 or either 2, then you have to jump. Okay, this is my necessary condition. If I want to go after this 2 index, then I have to take a jump either from 3, either from 1. Okay. This thing you have to understand first. Just visualize the example and just understand. Okay. Now if after this position, okay, I know this thing after this position I have to take a jump. Now how will I consider the next position after which I going to take a at least one jump? Means if I reach this position, it means that okay, no, if I want to go to the index which is higher than current index, then I have to take at least one jump. Okay, that is my statement. Because after any index, if I want to go to the index which is greater than current index, then I have to take a jump. Okay, so now if I am going here, okay, this one, if I want to go to the next values, okay, what I will do, I will know while iterating from 0 to second index, I will know my maximum reach. My maximum reach is this index 1 plus 3, that is fourth index. That you can understand. So when I was iterating in between, I was keeping my maximum reach index, okay, also. so that I can tell, okay, after maximum reach index minus I, that is this I, that is 4 minus I will be equal to 2. After this number of steps, after this number of indexes, after this ith position, I am going to take again one jump. This is because this is my maximum reachable index. Okay, this is my 1 plus 3, that is 4, and I know that after this 4 I have to take one jump. I don't know from where I'm going to take a jump. Either from this position you can take a jump, either from this position. But I know if I want to go to the next positions after in this case we are not having any positions. But if I want to go to the next position greater than 4, then I have to take a jump. Okay. So when I reach the last position, I will return my jump. Okay. So for this I will take a flag variable and my flag variable, and I will decrease the flag variable. And when my flag variable becomes 0, that will be equal to number of steps. For example, initially number of steps will be equal to this value, number that is equal to 2, because after this index I am going to increase my jump. So I will decrease the flag variable when it reaches to 0, that is this index. Okay, then I will increase my jump plus, and now I have to set flag variable as, okay, now I have to set the flag variable for the next number of steps. So what I will do, that's why I was calculating maximum reach. So my flag variable equal to m, that is my maximum reach, minus current I. After this number of position, I am going to take another jump. Okay, in this case that is m minus 4 minus 2, that is equal to 2. So when I am this index, I know that after two indexes, that is first index is this index, I am going to take a jump. But in this case there's no such thing. Okay, so when you reach the last index and you just return the answer. Okay, let me quote, you will understand. Okay, you will understand this thing. One second. Yes. So what I will do, firstly I will, okay, first in this case, nums what size equal to 0, sorry 1, because if there only one element is present, so it means that you don't have to take any jump, so you will return 0. Okay. Now I have considered the 0th index case. I will initialize my jump as 1, because I have considered the 0th index case, so I have written 0. Now if I have to consider all cases which is greater than equal to 0, and then I can initialize jump, so it will not be logically incorrect. Okay. Now what I will do, my next variable will be equal to that what I have told you. Initially it will be equal to console 0. Then what I will do, first flag jump, then yeah, max underscore reach equal to of 0. Okay. I think you understand what are these variables and what is the purpose of these variables. I told you there. Oh, I like that. Sorry, I like sometimes. I plus. Now condition is if I equal to nums dot size minus 1. Okay, when I reach the last index, I will return my jump. This is my basic. Okay, I have written something wrong here. As well as while iterating, I have to update my maximum reach as well, so that I can simply change my next flag variable. Okay, maximum reach equal to I plus nums. Now I will reduce my flag so that I know when I have to increase my jump, at least jump. So if flag equal to 0, what I will do, I will increase my jump variable jump plus plus, and I will change my flag variable as plus 40 minus I. Okay. Okay. And at last, what I will do, I will return my jump. Okay. Code is very simple. Okay. But for ON approach, you have to understand this thing. Okay. You just analyze this thing, just go through the question, just take a pen and paper and just do it by yourself. Do it by yourself. You will understand this logic. What are the meaning of these variables? Why I am using it? Am I what to use and what not to use? Do by yourself. Okay. And just try to practice this question because it's a very important question. Okay. Thank you very much for watching this video. I'll meet you in next video. Bye bye.